All right, everybody, we're on our last lesson, 7.4, simplifying expressions using the power rule. All right, so when we talk about power rule, that's whenever we have an exponent on top of another exponent. Okay, and we're going to learn and see what is the pattern whenever that's the case. All right, let's just start with the variables here. So in the past, if we wanted to expand something, we just went like that, and we had 3x's and we're good. And if we were to expand it, simplify it, that just brings us back, okay? Let's see what happens if we have a power on top of another power, or an exponent on top of another exponent. So here, let's just start with on the thing that's the furthest way out. So our outside exponent is a 4. And if that's our exponent, then what is the base? Well, here the base is what is inside that parenthesis. It's x to the third. So we're going to expand it. We're going to need to write x to the third 4 times. Okay, and then that can be expanded even further. We have, every time we have an x to the third, well, that is just 3 x's. That's a lot of x's, right? And if we were to add all of those, we'd end up getting 12 x's, or x to the 12th. Okay, so hopefully we're coming up looking at these exponents and see, well, what's the relationship? Could we go straight from here to here? And what would we need to do to those exponents to be able to get where we end up being? Okay, so let's look at another example. So again, we have our exponent is 2. Our base is what's inside that parenthesis. So that means we need to write 2x squared 2 times. Okay, and now we can expand that even further. We could do 2x times x times 2 times x times x. That means we have 4 x's. And then our coefficients, that's 2 times 2, so we get 4x to the 4. All right, so what's the relationship between those two numbers and this number? Let's try one more. All right, so now we have our exponent, our outside exponent. What's inside that parenthesis is going to be our base. So that means we're going to multiply the base by itself 2 times. So that would be 2x squared y to the third times 2x squared y to the third. All right, now we can expand those even further. That would be 2x x y y y, 2x x y y y. And then we have 4, well, let's look at our coefficients first. So we have 2 times 2, that's 4. We have 4 x's, so that's x to the 4th. And we have 6 y's, so that's y to the 6th. Okay, so what's the relationship that we come up with? Okay, what do we do to the 2 and 3? How can we use, how can we use 3 and 4 to give us 12? Perhaps that helps the most. Okay, so if we have an exponent on top of another exponent, what do we have to do? 3 times 4 gives us 12. Let's see if it works for the others. So here we do 2 times 2 gives us 4. 2 times 3, that gives us 6. 2 times 2 is 4. Okay, so if we have a power to a power, if we have an exponent on top of another exponent, we multiply the exponents. Okay, so this is kind of by words. If we were to do it kind of like a little equation, we'd do something like if we had x to the a, or a could be any number, and then we have on top of that we have another exponent that's a b, and it could be any number, then that would be x to the a times b. Or like one of our examples, I think we had something like x squared to the third, so that would be x to the 2 times 3, which is x to the 6th. Okay, so we've learned these three different rules, or I guess there's been more than that, but the main rules is if we multiply like bases, we add their exponents. If we divide like bases, we subtract the exponents. And if we have an exponent on top of another exponent, then we multiply those exponents. All right, so let's do the same thing that we've done with some of our other classes. Our lessons is we're going to expand and then simplify. All right, and again, if you just use the rule, perhaps that might be easier, but I think it's good to at least practice expanding a bit, and then you can do it however you'd like. So here we have, if we were to expand this, that's telling us that we're multiplying 2 to the third by itself twice. So that's like 2 to the third times 2 to the third. Okay, and that's just 2 times 2 times 2 for this one, and then we have 2 times 2 times 2 for the other one. That gives us 6 2's, so we end up getting 2 to the 6th. Again, the other way is just kind of say the rule, like the equation up here. If they're an exponent on top of another exponent, then we just multiply them. So that would just be 2 to the 3 times 2, which is 2 to the 6th. All right. Here's another example. So if you want to expand it, we're multiplying x to the 4th by itself 3 times. So that would be x to the 4th times x to the 4th times x to the 4th. And then if you wanted to expand that, I mean, you start getting a lot of x's. Okay, add those all up, you end up getting x to the 12th. Or, maybe easier, would just go x to the 4 times 3, which gives us x to the 12th. All right. If we were to expand this, we're going to multiply the base by itself twice. So that's 2x to the third times 2x to the third. If we wanted to expand, that's 2 times x times x times x times 2 times x times x times x. So 2 times 2 is 4. And we have 6 x's, so that's x to the 6th. If you were to do it the other way, then what we're doing here is, if we had like an exponent here, it would be a 1. So that would be like 2 to the 1 times 2, and x to the 3 times 2. So we'd end up getting 2 squared times x to the 6th, or 4x to the 6th. Okay? So basically everything that's in that parenthesis is going to have this exponent with it. Okay? So we're going to have 2, let me just erase that a bit. We're going to have 2 squared, and we're going to have x to the third squared. So everything in that parenthesis is going to be squared. So here's kind of the same sort of thing. We're going to do a negative 3 squared and a y squared squared, if that makes sense. So if we kind of did that, we'd do negative 3 squared and y squared squared. So that's, again, if it's a square to a squared or an exponent to an exponent, we multiply those. So we end up getting negative 3 squared Sorry, I should probably have a parenthesis on that, because that would be negative 3 times negative 3, which will give us a positive 9, and then we'd get y to the 4th. Okay, let's expand that one and see where we're at. So here we do negative 3y squared times negative 3y squared. Well, we know a negative times a negative is a positive, and that would give us 9. And then we have y squared times y squared. So we could expand that. That'd be y times y for our y squared, and another y times y. And that would end up giving us 9y squared. Okay. Here are some others. So expanding, but if we want to expand, we can't do it if we have negative exponents, so we need to bring it to the denominator. So if we do that, we need to bring it to the bottom and change its sign. So here's our exponent, here's our base, our coefficients out in the front. So the coefficient stays, and then we'll bring everything else to the bottom. So 2x to the 6th to the positive 4. So again, if you bring it down, it changes the sign of that exponent. All right, now we can expand. So 2x to the 6th times 2x to the 6th times 2x to the 6th. We're doing it 4 times. Whew, this is going to give us a lot of x's. So now we'll have 1 over, well, we have 2 times 2 times 2 times 2, and that would be 16. And then we have, that's 6 x's, 1, 2, 3, 4, 5, 6, and then we need to do it 3 more times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Holy moly. Okay, so that's a lot of x's. And expanding, again, sometimes expanding is not the best, okay? But if you were to add all of those up, you would end up getting 1 over 16x to the 24. Okay, let's try and do it the other way with just like using the equation thing that we came up with. So if we have a power to a power, we just multiply their exponents. Okay, so maybe see if this is easier. So we'll just start from here because we needed to get rid of that negative exponent either way. And we'll end up getting 1 over, okay, we'll have 2 to the 4th, and then we'll also have x to the 6th times 4. Okay, and you could do that on your calculator, 2 to the 4th, that gives you the 16, and 6 times 4 is 24. All right, so pause and give these last two a try if you haven't been trying to do that. I think that'll be good. All right, so let's expand. Let's try doing this expanding. All right, so we have a 3, and we have an x, and an x, and an x, and an x, and an x. On the bottom, we have x to the 3rd to the 3rd. So we're going to do x to the 3rd times x to the 3rd times x to the 3rd. If we wanted to expand even further, then we're going to have x times 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 x. Then you could cancel some of these x's, and that leaves us with, looks like we have 4 x's left in the bottom. So that would give us a 3 on the top and an x to the 4th on the bottom. All right, a different way we could do this is we could use, since we have a power to a power, we multiply them. So that gives us 3x to the 5th on the top and x to the 9th on the bottom. And then, since they are being divided by, we'll subtract those exponents. So that would be 3x to the 5 minus 9. And that gives us 3x to the negative 4. And then we'd need to bring that to the bottom. The 3 would stay, and then the x would go to the bottom and would change its sign. So again, they end up being the same, just depending on the way that you want to do it. All right, and last but not least, Looking at the top, if we want to expand, we are going to multiply. There's going to be, this tells us how many there's going to be when we multiply them together, and there's 0 of them. Our coefficient in the front would be a 1. So all we have left here would be a 1 on the top. And on the bottom, we have, if we were to expand it, we're going to multiply the base by itself 2 times. So 4x to the 4th times 4x to the 4th. And if you want to expand that further, would have 4xxxx times 4xxxx. And that leaves us with 8 x's. And then our coefficients would be 4 times 4 is 16x to the 8th. Again, if you wanted to do the other way, going from here, we had 1 on the top, and then 4x to the 4th squared. Okay, again, that means that the 4 on the top, on the bottom, will be 4 squared, and the x to the 4th squared would give us x to the 4 times 2. That gives us 1 over 16x to the 8th. So the same thing we get before. All right, last but not least, expression, we want to express the area of each square below. Looks like they're both there, okay? So these are square. That means that all the sides are the same. So the length is the same as the width, okay? So another way you could do this is the area of a square is length squared. Missed the G. Okay, so if we want to find our area, all we need to do is x squared y to the 4th, and then we square it. Another way you could do that the same way would be, since length is the same as the width, you could just multiply it by itself twice. So either way, these are equivalent, just depending on how you want to do it. So length squared or length times length. All right, and so we have like bases. Here we could just add those exponents, so x to the 4th. And then these are like bases. That'd be y to the 8th. Again, if we're multiplying like bases, we will add their exponents. If you had it the other way, if you did the x squared y to the 4th squared, then we'd do the same thing that we did above. This is probably more what I'm trying to get us through. Since it's a power to a power, exponent to an exponent, we will multiply. So that would be x to the 2 times 2 and y to the 4 times 2. That's x to the 4th, y to the 8th. You get the same thing. Okay, so give this one a try if you would. It's also a square, which means that this side is also 6x to the 8th. This is also 6x to the 8th. Okay, if we want to find our area, we just do length times width. So 6x to the 8th squared. That's 6 squared x to the 8 times 2, or 36x to the 16. Okay, or again, you could also do 6x to the 8th times 6x to the 8th. And then multiply the coefficients as normal, that's 36. And then if we're multiplying like bases, then we would add. So that would be x to the 16. All right, so here's just a recap of all the exponent rules that we've covered. If we're multiplying like bases, so those are like bases and they're being multiplied, that means we would add those exponents. If we're dividing like bases, then we subtract It's always top minus bottom. Power to a power, or exponent to exponent, we multiply a times b. 0 exponent, that would be 1. X to the 0 is 1. And then if we have negative exponents, then we need to bring it to the bottom and change its sign, the sign of the exponent. Or if it's on the bottom, then we bring it to the top and we change its sign. Okay? Coefficients, you multiply or divide as normal. All right. Sorry. Okay. Again, please let me know if you have any questions. I'd love to help you out. All right. We'll see you.